drop. Potential drop, sometimes it is called back EMF. Potential drop, what we have done, that is sometimes called back EMF. That is, whatever EMF is inside the electrolyte or inside the cell. So relations we have already derived. So we'll continue from that relation only. So this I was E by R plus R. This was the relation. This V was ER by R plus R. This V was also E minus IR. Is V plus V. This V we call potential drop or back EMF. This was V plus I into small r. So these are relation we have derived yesterday. Efficiency was R by R plus R. So till here we have done till efficiency. So from this expression only it is very clear that efficiency will be large or nearly 100% when for large efficiency this R must be much more than R is separately R1. So external resistance must be very high in comparison to internal resistance. That is for larger efficiency. Nearly it will come 99% or 96%, 95%. For that, the external resistance must be very large. Now, for maximum power transfer, that is, the source will able to transfer the power or the rate of energy transmission, we can say, the rate by which energy is transmitted from the source to the load. That is power transmission or energy transmission per unit time. So what is the relation power? We have done yesterday. This P was I square R or V square over R, or it was V into I. Now suppose you are asked for which value of external resistance or what is the relation between external resistance and internal resistance for the maximum power transfer. So for maximum power transfer, find relation between R and R, or relation between R and R for maximum power transfer. So as we know, this P is I square R. E by R plus R whole square into R. So here whatever R we have taken, this R, capital R, that is external resistance. If only one external resistance is connected, then that is the value. If circuit has got so many resistance, then that will be equivalent external resistance. So in general we say this R is what? Equivalent external resistance. And small r we say internal resistance of the source. So here, this R or this R variable, this R we are not able to change. That is the property of the source. We are able to change this capital R. So what will be for P to be maximum? What is the condition? dP over dr must be 0. Sorry. So if we differentiate this with respect to R, it should be 0. Because we want to know what is the relation between R and R. Capital R we can change. In place of 2 ohm we can apply 5 ohm. In place of 5 ohm we can apply 10 ohm. That we can vary. But the small r we can't change. So we will keep capital R as variable. So d by dr of E square R by R plus R whole square must be 0. E is constant, so we'll keep it out, no problem. So this E square, now differentiation of this, what will come? R by R plus R whole square. What is the differentiation? If we differentiate with respect to R, what will you get? Yes? Whatever.
They're doing, sir.
Yes, differentiate R by R plus R whole square with respect to R. Differentiation we have finished, no? Integration only left in class, in math calculus. Differentiation we have done.
So R plus R whole square minus R. Calculation
So this is R plus R
whole square.
Q by V. So what will
Yes,
come?
sir, whole square.
4, no.
So that will be down. Yes, sir. Up one.
Huh?
Sir, I was telling up one.
Okay, what is that?
R plus R whole square
R plus R whole square.
minus R
Differentiation of everyone minus R.
half R plus R
Hmm?
half.
Half.
No, sir. 2 R plus R. dr by d.
This one only? Here 1 plus 0 will come. Okay, so this must be 0. So this will go that side, multiplied 0, E square come that side. R plus R we can take common. So what is left? R plus R minus 2R will be 0. That is, this R is equal to R. So when external resistance and internal resistance both are same, then the source will able to transfer energy very fast or maximum rate. That is, if you want to charge your mobile, suppose here we want to charge our mobile, then what is the source? Source is the charger. What is the load? the cell of your battery, means mobile. So if you want to charge your mobile within less time, what should be the condition? The resistance of your mobile and resistance of the charger, internal resistance of the charger should be same. But what is the loss in this case? For maximum power transfer, what will be the efficiency? So it is 0.5 or 50%. That is 50% energy will be lost. 50% energy will be transferred into other form. Maybe, most probably, it will be in form of heat only. So we don't prefer this one, because here much energy will be lost. So at the time of maximum power transfer or maximum current drawn from the source, what will be? The energy, much energy will be lost. So we don't prefer this one. Always we prefer to charge the mobile or to charge the inverter battery at small current or by small current only. Current should not be large. If large current means larger power will be transferred, and in that case, much loss in energy will be there. So for better efficiency, external resistance must be much more in comparison to internal resistance. But for maximum power transfer, these two should be equal. These are the two different situations. Now, power, energy consumed by electrical appliance. Power energy consumed by electrical appliance. And calculation of electric bill. This also we have done in class 10. So if we pass any current through this appliance, appliance means some load will be there, some resistance will be there, or whatever we are using just to transform energy from one form to, means electric form to other form. So that electrical appliance is converting. So generally that resistance will be there. In some cases, in place of resistance, some other principle is used. So here we are going to discuss in terms of resistance only. So as we know, this potential difference between VA and VB, that is I into R, according to Ohm's law. If current I is passed through this, potential difference will be. Now work done by source, here current is passed through the appliance. So from the any source it is coming, maybe the cell, maybe the mains, maybe the generator, whatever the source is there. So that source is not important. Here we are concentrating on this appliance, whether it is heater, whether it is electric iron, whether it is fan, whether it is tube light, whatever, or refrigerator or microwave, whatever you are using. So we are concentrating on this appliance only. So current I is passed through that appliance. In general case, what will be, all the appliances will have, whatever we are using at home, all the appliances potential difference is same, that is 220 volt only. But here we are applying, we are connecting to the earth in means in parallel only. We are not connecting in series. So potential difference of all the appliances will be same. What will be the current passing through that? That will depend on its resistance. So this potential difference is IR. How much current will pass? That will depend on the potential difference, which is fixed 220, and the resistance. Now this work done by source or electric field. What was that formula? If we move charge dq from A to B, work done from A to B, what will be? Charge into potential difference between A and B. In case of source, this will be. In case of external agent, VB minus VA. We are interested here of what is the work done by the source, because source is giving energy to the appliance. That's why A to B means here VA minus VB will come. Got the point? In case
Yes,
of external agent, work done in moving charge from A to B will be the charge into VB minus VA. But by source, this one. If it is very small one, because potential is so much varies, then in that case, what will be, this dW will be dQ into V, where V is potential difference, VA minus VB. That is, so what will be the average power work done by time? Or given limited. Instantaneous power. So V into dQ by dt. So this instantaneous power will be, this dQ by dt is the current, instantaneous current, I into V, and here will be what? Average power if you are taking then. This is the average current. So V into I, where I we call average current. Okay, average. So here will be V into I, that is instantaneous current. So whatever potential difference is at that instant and whatever current is passing through that instant, the product of these two will give the instantaneous power. For average power, we have to take average current. Numericals will be based on this one. So this average power can be, so V into I, in place of V we can write IR, so it can be I square R or it can be V square over R. This already we have done previous one. So here, this is the which power it is. This is the rate at which the source is giving energy to the appliance. That is, the appliance is consuming energy. Appliance is producing energy, that is not the case. So when we say power of an appliance is 100 watt, it means it is consuming 100 joule electric energy per unit time or per second. It is not that it is converting 100 joule energy into useful form. It is consuming. That is the electrical power of appliance. So this is the difference. Mechanical power is what? How much work is done per unit time. But here electrical power of appliance is how much electric energy is consumed, not produced, not transformed to other form. No? For example, suppose the power of an electric fan is 75 watt, it means it is consuming 75 joule energy per second. How much it is converting into mechanical energy, that is not given. That is not marked. What is the efficiency of that electric fan? You will not get anywhere. That is not given in the, when you will purchase the fan, that information you will not get. Only that much information is there, how much energy it is consuming. So this is the difference between mechanical power and power of an electrical appliance. So power of an electrical appliance is the amount of electric energy consumed by it per unit time. So this is the meaning of power of electrical appliance. How much energy is consumed by it. If appliance is 100% efficient, then whatever energy is consumed, same will be output power also. That is energy transmitted into or transformed into other form. So if appliance is 100% efficient, useful form will be equal to energy consumed or electric energy consumed. During the same interval of time. So generally in case of heating, electric heater, geyser like that, if efficiency is not given, then whatever heat is produced, we will calculate by the same formula. So whatever the power is consumed, same power is produced also, if efficiency is not mentioned in the question paper. Now this energy consumed by electrical appliance. This will be its power into time. So generally, power of electrical appliance is known or given. We will multiply it by time. That will give the energy consumed. So it can be given like this: VIT, it can be I square RT, it can be V square over R into T, or it can be Q into this. I into T is Q, so it can be Q into V. Units of the energy you are knowing. So what are the SI unit? Its unit will be same watt power. SI unit of power we are taking watt. Okay. Units of power and energy. SI unit. This is watt. So 1 watt means 1 joule per second. Nowadays we are not expressing in watt. In place of watt, other units so one is volt ampere, VA. kVA, kilovolt ampere. Nowadays, frequently these units are used. So this one VA voltage, joule per coulomb, ampere is coulomb per second. This is 1 joule per coulomb and this is coulomb per second. So that is watt. So volt, ampere and watt numerically same. But why we change this definition or why we change the unit? We are nowadays, it is not expressed in watt. Why is it so? So what is that? Suppose we are saying the power of a bulb is 100 watt. What does it mean? It will consume 100 joule energy per second provided connected to a source of proper voltage. Now, what is its proper voltage? That will depend on the bulb. A bulb, suppose it is marked 100 watt 220 volt. Other bulb is marked 100 watt 180 volt. This will consume 100 joule energy in 1 second when connected to this source. Whereas this second bulb will consume 100 joule energy in 1 second when connected to this source. Now, if this bulb is connected to this source, what will happen? Its power will be different. It will not consume 100 watt. This type of numerical we have done in class 10. Here also we have to solve. So its power will be different. It will become less. That's why nowadays we are not defining this power, electrical appliance power, like in watt. In terms of now we are giving VA. Now what does it mean? Suppose it is written power of the bulb is 100 VA. What does it mean? If you are connecting this bulb to 100 volt and drawing a current of 1 ampere, power of the bulb is 100 volt, 100 watt or 100 volt ampere. If you are connecting this bulb to 50 volt source, it will draw 2 ampere current. If you are connecting this bulb to 200 volt source, it will draw 0.5 ampere current. So that is the information now very clear. Now that condition is removed. That's why nowadays this VA or kVA is used. kVA means what? kVA means kilowatt, because VA is what? So it is 1 kilowatt or 1000 watt. So kVA means 1000 VA. So in place of 100 watt nowadays we use 100 VA. Now unit of energy. So SI unit of electric energy. The same joule only. So 1 joule means if an appliance of power 1 watt or 1 VA is used for 1 second, the energy consumed will be 1 joule. Other units are VAS, kVAS, watt hour, kilowatt hour, kVAH. One VAS. VA means what? So 1 watt second. So it is 1 joule. Similarly, kVAS. One kilojoule. Watt hour means 1 watt into 3600 second. So 3600 joule watt into second. These all we have done in class 10 also. Kilowatt hour, 1000 watt into 3600 second. Or 3.6 megajoule. kVAH. That means 1 kilowatt hour. So 3.6 into 10 to the power 6 joule. kVAH or kilowatt hour. Numerically both are same. Yes. Any doubt? No. No one has got any doubt?
No, sir.
Okay, then we shall continue. So this is the unit of power and energy. Now you see the relation, this power we have got, one relation says it is V square over R. Other relation is saying it is I square R. According to this relation, P is inversely proportional to R. Whereas according to this relation, power is directly proportional to R. Which one is correct? According to this relation, P is inversely proportional to R. That is, if resistance is more, its power will be less. According to that relation, it says, if resistance is more, power will be more. Is it possible? Yes?
I guess the second one.
Huh?
Sir, I guess the second one.
Second one is correct. But relations both are correct only, no? Any other? This relation also correct. If we change V into IR, what will be I square R square by R? Then I square R will be getting. Any other? Yes? Both are correct. Provided here, what is the condition? If V is same, so power will be inversely proportional to R if V is constant or V is same. That is, if appliances are connected in parallel, Generally in wiring system, appliances are connected in parallel. Only for the, at the time of decoration, that is small bulbs, they are connected in series. So when connected in parallel, we are knowing potential difference will be same. Series and parallel connection we are knowing. In class 10 we have done. Here also syllabus is there, but I have not done purposely because you are knowing. Derivation is not there, only we have to know what is happening in series combination, what is happening in parallel combination. So here in this case, what will be if I is constant? That is, if resistors or appliances are connected in series. So when appliances are connected in series, then power of that appliance will be more whose resistance is more. That is, energy consumption will be more whose resistance is more. But here it is the reverse. If the appliances are connected in parallel, then power consumption of that appliance will be more whose resistance is less. Or indirectly, if you are saying we are taking an electrical heater of 2 kilowatt and an electric bulb of 100 watt, whose resistance will be more? Can you guess? Electrical heater of 2 kilowatt or a bulb of 100 watt, whose resistance will be more? So naturally, that bulb will be having more resistance. Those whose power is less will have more resistance because they are connected in parallel only. Whatever the appliances we are using in household, all are connected in parallel. So we can compare their resistance. A bulb of 20 watt will have more resistance in comparison to a bulb of 100 watt. Okay, so in this case, what will be if we are asked to find the power P1 by P2 will be how much? And it will become R2 over R1. This is if V is same. Frequently we use this relation. And here what will be? This P1 by P2 will be R1 by R2. If I is same. Current will be same when they are connected in series. So when you are asked to compare the power of two bulbs when they are connected in series, then that relation you have to keep in mind. Now, frequently this question is asked.
So R2 by R1 to be.
Yes.
R2 by R1.
What happened?
So there it will be R1, sir.
Not getting?
So there it will be R1, sir.
Okay, where it will be R1? Oh, here. R2 bar. So if the two resistors are connected this way, suppose this is R1 and this is R2, they are connected to any source, then their power can be compared by or find, if you are asked find the ratio of this power, it consumes electrical energy per unit time P1, it consumes electrical energy P2, then P1 by P2 will be R2 by R1. And if they are connected in series, so in this case, what will be? The current passing through them will be same. Here current will be different. This will have, suppose I1 current, this will have I2 current, but potential difference will be same. So in this case, P1 by P2 is R1 by R2. That you can say. If this one has got more resistance, its power will be more. Now, electric bill, calculation of electric bill. So, electric bill is expressed in terms of, we call it commercial unit or simply unit. So, commercial unit or unit of electric energy consumed is kilowatt hour. That is 1 unit means 1 kilowatt hour. So, first of all, we will express whatever energy is consumed in this unit. So, how we find number of units consumed? Number of units consumed will be, for that we have to take power in kilowatt, time in hour. Sometimes will be given time this much hour per day. Then into number of days will come. If number of, suppose 5 bulbs are there, means all are identical, then into number of appliances will also come. So this time, suppose you are asked the number of hours per day, then into number of day will also come. Hour per day, and you are asked monthly bill. Then 30 days we will find. If power is given in watt, then we will divide by 1000. Anyhow, we have to express in kilowatt. So if power you are taking in watt, then by 1000 will also come. So we will find first the number of units consumed. And then what will be the electric bill? Total number of units consumed into rate. Whatever rate is given, suppose 4 rupees, 5 rupees, whatever it is given, so we'll multiply by that. So this way we can calculate electric bill. If you are asked find the energy consumed in SI unit, then power will take in watt, time will take in second. So if not in electric bill, if you are asked energy consumed in SI unit, then we have to take power in watt and time we have to take in second. Yes, any doubt? Till here, any doubt? No.
No, sir.
Okay. So for you are interested to find the electric bill of your house or your classroom only. Suppose how many friends were there in your class?
6.
6. Okay. So in class 11A, six fans, each of 75 watt. Runs for 6 hours per day. How many tube lights were there? Okay. Each of 75 watt. How many tube lights?
1.
Only one. Okay. One tube light of 40 watt. So in class 11A, there are 6 fans each of 75 watt, one tube light of 40 watt, 40 only. Projector of 500 watt. If all are used for 6 hours per day. Find electric bill of month of July 2019. Cost of each unit is 750 rupees. Suppose this is the situation. Okay, now you calculate what is the electric bill. So, in this case, what will be? We'll find number of units. or directly you can find total number of units. In okay, July will have 31 days. So what will be now? 6 fans are there. So 6 into 75, that is total power by 1000. This much kilowatt. Now all are running at the same time. If they are different, then only we will find number of multiply. We can multiply as all are running for same time. Or suppose you are given if fan and tube lights, if fans and light are used for 6 hours per day and projector for 4 hours. Per day. Now it is different. So here it is running for 6 hours plus 40 watt of the tube light is there. This is also 6 hours plus this projector is of 500 watt. This is of 5 hours. Into 31. This is 6 hours per day, 6 hours per day, 5 hours per day. Then into number of days will be multiplied. How much it is? You can find separately, okay, what is the number of unit or what is the energy consumed for this, for that. It will take longer time. So try to do in short only.
168.64.
Yeah, how much?
168.64.
168.64.
64.
Now what is the bill? Electric bill for July 19, okay. 168.64 into rupees 750. How much it is?
One two six 4.8.
1,
2
2, 6,
6 4
1264.
1264.8.
0.8, okay. So this bill will be 1,265 rupees. And how much you are paying? Electricity charge? Very less. This is the bill of 1 month of your class, not whole school.
Sir, management.
Eh?
Management.
Management. Okay, so this way you can calculate of your house also. Your house will be, rate will become nearly 450 because government is giving subsidy. Here, commercial rate will be of the school will be much more, not 750. It is more than that. That is domestic unit rate is different, commercial unit is different. So for your house, you can calculate the bill. The rate will be nearly 450 rupees, 4 rupees 50 paise. Okay, now suppose you are asked a bulb is marked 100 watt, 200 volt. What are the informations that we get from this marking? Why this marking is given on the bulb? So what are the information that we get from this? What is the meaning? If this bulb is connected to a source of 200 volt, it will consume 100 joule energy per second. That is one information. So if bulb is connected to a source of 200 volt, the energy consumed by it is 100 joule per second. That is the meaning. If you are connecting the source less than 200, what will happen? The voltage of source is less than 200. What will happen? Will the bulb glow? Yes?
No,
Will the
sir.
bulb glow? It will glow, but it will not glow full bright. Its power will decrease. No? It will glow less as its power decreases. If you are connecting this bulb to a source of more than 200 volt, what will happen? It will glow more bright. Yes?
Fuse will be.
What will happen?
I guess fuse only.
Fuse.
Yeah?
Yeah, fuse, I guess.
Fuse.
Bulb will fuse. So that is the safe voltage we say. It should not be, voltage of source should not exceed 200 volt. So if voltage of source is more than 200 volt, it will fuse. Or any other appliances, the appliance will be damaged. Any electronic device is there, whatever voltage it requires, if you are giving more voltage, then we will not say but appliance will fuse. the circuit of the appliance will be damaged or appliance will be damaged. Now, what is the other information? So, resistance of the bulb. That we can find V square over P. That is 100 in, sorry, 200 into 200 by 100. So 400 ohm. That we can find by this marking. So what are the importance of this marking? What are the information that we can get? So resistance we can find, maximum current that can be passed. Or we say maximum safe current. So this is P over V. 100 watt over 200 volts. So 0.5 ampere. If anyhow, by connecting it in series or in parallel, if current exceeds 0.5 ampere, the bulb will fuse. Sometimes it is asked, what is the fuse rating? Fuse rating we have done in class 10. So what will be the fuse rating for this particular bulb or any other appliance if it is asked? Then fuse rating will be slightly more than the maximum current that can be passed through that appliance. So what will be the proper fuse? The fuse rating of that fuse will be more than 0.5 ampere. If 1 ampere fuse is available, then 1 ampere fuse will be connected in that particular circuit. So these are the information that we can get from here. Now suppose you are asked, in the above question, find the power same bulb when connected to a source of 150 volt. If that bulb is connected to a source of 150 volt, what will be the power? Will it be 100 watts? Naturally, it will not be 100 watts. So how much it will come? So in this case, what will be, once you change the source, V will change, current passing through that will change, power will change, but what will remain same?
Resistance.
Resistance of the filament is not going to change with the source voltage. So resistance we will use.
Sorry,
So from the
56.25.
mark, we will find the resistance of the filament. So resistance of bulb will find. This R will be whatever voltage is marked and whatever power is there. So here voltage which will take mark 1 by the power. Power also the mark 1. So it is 200 into 200 by 100.
400.
400 ohm will be the resistance of that filament, and it will not be affected by the source voltage. Whether you are connecting by a source of 50 volt or 100 volt, this is not going to change. Now, what will be the power?
56.25.
So, power of same bulb when source voltage is 150 volt. So here we will take source voltage by resistance. So 150 into 150 over 400. .25 watt will become. Naturally, the glow of this bulb will become almost 56%. So 44% glow will decrease. Now, if it is asked in the above question, find the power of the same bulb when connected to source of 250 volt, what will be?
It will fuse.
So
The
will
bulb
not
will fuse.
power like this. If it is more than that mark 1, simple answer will be the bulb will fuse. It will not, or any appliance is there, then it will be damaged. Okay, this is how to calculate electric bill, or what is the meaning of this one. Now, frequently, sometimes it is asked if two bulbs (20 watt and 100 watt) each mark 200 volt is connected in series to a source of 200 volt. Which bulb will glow more? Or sometimes you will be asked, find the power of the individual bulb. So what will happen in this case? (20 watt bulb and 100 watt bulb. 200 volt. 100 watt, 200 volt. They are connected in series to a source of 200 volt. Now, so what is the resistance of this one? (200 into 200 by 20). So it is 2000
2000.
2000.
2000 ohm, and here is 400 ohm. Which will glow more? Which bulb will glow more? Actually, this one will glow more. As they are connected
Yes,
in
sir.
series, current will be same.
Yes.
So current is same. Here power will become I square 2000, I square only 400. If you are interested, you can find I also, and what is the power? What will be I? 200 V total resistance is 2400 ampere. So 1 by 12 ampere. What is the power of first one? I square R. 1 by 12 square into 2000. What is the power of second one? 1 by 12 square into 400. So it is 2000 by 144. This is 400 by 144. So this power will become more, almost 5 times. Though this bulb has got more capacity of glowing, but it will not glow now more. This one will glow more.
Sir, we can use that relation also, no, sir. When
Yeah.
current is same, that you gave that
Yeah,
relation.
if it is asked,
Power is
if
directly
region is asked,
Yeah.
if only region is asked, which one will glow more and why, then simple answer. As the current is same, but resistance of this bulb is more, so power of the 20-watt bulb will be more, and it will glow more.
Sir,
If you are asked, find the power of each bulb, then this calculation is required. Otherwise, calculation is not required.
Okay.
sir,
Yes.
sir, how the 2400 is coming, sir?
They are corrected in series.
Oh,
So series equivalent is what?
mhm.
I will be V by total resistance series equivalent. I think you have to do that one also. Series and parallel equivalent.
No, sir.
No. Okay.
Over, sir.
I think so. You want more?
20
No.
minutes extra you taught, sir.
Eh?
Or I will study 15 minutes only.
So 15 minutes extra you taught us, sir.
50 minutes? No, it cannot be
15 minutes.
15.
Sir, you were in a good flow,
That
therefore
is
we didn't
normal.
interrupt
You are
you, sir.
in class.
So next day, 15 minutes you don't
Okay,
be.
very good. Thank
Continuously
you.
studying is a good
Thank you,
practice.
sir. Thank you, sir.
Thank you, sir.
Next, we will continue. Whatever you
Thank you. Okay, sir.
Thank you.
Thank you, sir.